Hello, this is Mr. Huber. In this lesson, we're going to learn about zero and negative exponents. So let's see a couple examples. We can use some properties of quotients to understand what happens with zero and negative exponents. So in this first example, we have x to the fifth over x to the fifth. Let's just think about in terms of a fraction. When we divide something by itself, right? A fraction is division, numerator by denominator. So if we had like 2 over 2, 10 over 10, negative 8 over negative 8, anytime you divide something by itself, you should expect that it would be equal to 1. If we look at what our property of exponents would tell us here, we would take x to the 5 minus 5. Dividing like bases in that quotient, we can subtract the exponents. So that'd be x to the 0. So this tells us that x to the 0 is in fact equal to 1. Okay? And anything to the 0 power will be equal to 1. And that's why. Anything to the 0 power, 5 to the 0 power is equal to 1. X to the 0 power is equal to 1. 87 to the 0 power would be equal to 1. So anything to the 0 power is equal to 1. So that's a property to know about 0 as an exponent. And 0 to any power will be equal to 0. Okay, so for instance, if I had 0 to the fifth power, I can multiply 0 by itself as many times as you want. That's going to be equal to 0. So know the difference there. Okay, when we have 0 as an exponent, it will always be equal to 1. 0 to any power will be equal to 0. Now let's see what happens in this next example. We have x to the fourth over x to the seventh. So that would be x to the 4 minus 7, which is x to the negative third. Let's look at what this would be if I wrote out the x's all multiplied together in the numerator. I'd have 4 x's. In the denominator, I'd have 1, 2, 3, right? Because an exponent is how many times I multiply something by itself. So I'd have x to the seventh, that'd be 7 x's. If I cancel out common factors, x and x, I can keep going through. I'm going to cancel out all 4 x's in the numerator and 4 of the x's in the denominator, and I could see I'd have x to the third in my denominator. So these are equal to each other. X to the negative third is equal to 1 over x to the third. And standard form will tell us that we don't want to have final answers with negative exponents. A negative exponent means that it's written as its reciprocal. If something's in a numerator with a negative exponent, we can move it to a denominator with a positive exponent. All right, this x to the negative third will now go to the denominator as x to the positive third. If we have a negative exponent in a denominator, it'll move that base to the numerator as a positive exponent. So we're going to see those examples, but remember, anything to a 0 power is equal to 1, 0 to any power is equal to 0, and when you have a negative exponent, it means we write it as its reciprocal with a positive exponent. Okay? That's these properties we see here. Okay? So again, a to the 0 power is equal to 1. Anytime you take any base, whatever a is to the 0 power, it'll be equal to 1. As long as you don't take 0. 0 to the 0 power, that's a little different. Okay, so 5 to the 0 power is equal to 1. We have negative exponents. So a negative exponent can be written as its reciprocal as a positive exponent. So 2 to the negative first would be 1 over 2 to the positive first. If we had 2 to the negative first in the denominator, it would move to the numerator as 2 over 1. We don't necessarily have to write the over 1 part. Okay, so keep that in mind what happens with negative exponents written as reciprocals. All right, so let's try some example problems here. And we're going to write these with positive exponents and then actually evaluate them as well. So in this first example, 4 to the negative third. So the first thing we could do is write that with positive exponent, 1 over 4 to the third. 4 to the third is 64, so that'd be 1 over 64. In the second example, we have negative 2/3 to the 0 power. Again, I don't care what's in the parentheses there. This can be anything you want. When it's to the 0 power, it's equal to 1. Then we take 3 over 5 to the negative second. 3 over 5 to the negative second means I'm going to write that as a reciprocal, 5 over 3 to the positive second. Right? Reciprocal now to a positive power. And then that would be equal to 25 over 9. Now this next example is a little odd. We said 0 to any power is equal to 0. And that's true. This would be 1 over 0 to the 7th, which is undefined. We can't have a 0 in a denominator. So this would be undefined. So be aware of that negative exponent is going to still be to the 0, but it's in the denominator, so that makes it undefined. Okay? So keep in mind here what happens with negative exponents. They get rid of reciprocals. Anything to the 0 power is equal to 1. Right? We have a reciprocal here. 3 to the negative second would go to the denominator. The 5 to the negative second would go from the denominator to the numerator, right, as it's reciprocal. And then we can evaluate. So when it says evaluate, we want to get an actual value, okay, not written just with exponents. So let's look for directions on those types of things to see if the problem asks to write it with positive exponents to evaluate so we can give the proper final answer the way we want to. All right, before we see some more examples with 0 and negative exponents, where did the Pistons basketball franchise originate? I'm going to show you the rest of that logo there. That was their original logo. The Pistons weren't in Detroit originally. They were in Fort Wayne, Indiana. And that was their original mascot. They're actually founded by Fred Zollner, who owned an auto manufacturing parts company, and they manufactured, as you might guess, pistons. So that's why they were called the Pistons. And they were actually started as a company work team. Semi-professionally, they just played, guys who worked for his company. They just played some basketball. And after a couple years, so in 1937 that started. In 1941, they joined the National Basketball League, became fully professional. They actually won 2 NBL championships in 1944 and 1945 as the Fort Wayne Zollner Pistons. And then later on, they joined the Basketball Association of America in 1948. And that was one of the leagues that formed the NBA. Fred Zollner, actually the NBA was formed partially by him. They sat down in his kitchen and came together with the framework to put together the leagues that formed the NBA in 1949. And they dropped the Zollner part and just became the Fort Wayne Pistons before moving to Detroit in 1957 to become the Detroit Pistons. So the Fort Wayne Zollner Pistons were the original franchise of your current Detroit Pistons. All right, let's see some more examples of properties of exponents, dealing with negative and 0 exponents in particular. So in this first example here, we want to use our product property, 5 to the negative third times 5 to the third. When we multiply like bases, we want to add the exponents. So we're going to add negative 3 plus 3, which would be 0. So 5 to the 0, this would actually be equal to 1. All right, and then next example down, we have 1 over 8 to the negative second. So because we have a negative exponent here, that's going to be written as its reciprocal and move to the numerator, 8 to the positive second. You can put the over 1, you don't necessarily have to. When you have something over 1, you can just write it as its own. So 64 over 1, or just 64. We don't have to write the over 1. In the next example, we have 3 to the third to the negative second. So when we have a power raised to another power, so here we have a power raised to another power, we multiply those exponents together. So this is going to be 3 to the negative sixth. Okay, so 3 to the negative sixth, we're going to write as its reciprocal, 1 over 3 to the sixth. And then 3 to the sixth is 3 times 3 times 3 times 3 times 3, 6 times, right? So we're going to have 3 to the sixth power is actually equal to 729. So this would be 1 over 729. All right, next up, the top of that column over here, so we're moving up here. Again, we have a power raised to a power, so we're going to take that and multiply those exponents together. So when we do that, we're going to have 5 to the positive third. Okay, negative 3 times negative 1, right, would be a positive 3. So now we're going to have 5 to the third is 125. 125 there. Right? In our next example, 6 to the negative second over 6 to the second, so we're subtracting exponents because we're dividing like bases. So this would be 6, negative 2 minus 2. Pay attention and make sure we're careful with our negative numbers here. We're adding and subtracting with negative numbers or multiplying by negative numbers. So this would be 6 to the negative fourth, not negative second, negative fourth. Okay? 6 to the negative fourth, which would be 1 over 6 to the positive fourth, right? So we'd have 6 to the positive fourth there, and if we multiply that by itself, okay, we're going to get 1296, so it's 1 over 1296. That's what we get for 6 to the fourth power. Right? So again, evaluating here, we can write with positive exponents, and then we can evaluate those. So now we'll move on to our example number 10. and we have 7 to the third over 7 to the fifth, we're going to subtract. So it's 7 to the negative second, which is 1 over 7 to the positive second. That's 1 over 49. Okay, so the properties of exponents don't change if we have a negative exponent, right? When we're multiplying like bases, as we saw here, right, we can add the exponents. If we're dividing like bases, like we saw over here, we subtract exponents. We have a power raised to another power, we multiply the exponents. And then pay attention at the end, we don't want to have a final answer with a negative exponent. We can write it as a positive exponent, like something here, okay? Or here, right, as it's reciprocal with a positive exponent. And then evaluate, we're going to be able to take those and come up with actual values for those numbers. Okay? So you should be practicing these as we go through. Hopefully you had good understanding on some of those, or seeing where maybe there was some misunderstanding that you can get cleared up as you continue to practice these problems. Let's simplify a couple longer expressions here. A little more work to do on some of these. Okay, so we're going to simplify, and as you can see here, it says we're going to write our final answer using only positive exponents. Right? So in this first example, in parentheses, everything in the parentheses here is to the third power. So let's take everything to the third power. So that means we're going to have 3 to the third power. X to the negative sixth, because negative 2 times 3, a power to a power, and y to the 12th. So the next thing we could do is we'd have 3 to the third, y to the 12th, over x to the positive sixth. Right? Only the base with a negative exponent gets moved as its reciprocal from numerator here to denominator with a positive exponent. And then we could also take this and we could multiply 3 times 3 times 3, and we could write a final answer of 27y to the 12th over x to the 6th. So follow our properties of exponents, and when we have those negative exponents, know what to do with those in terms of writing reciprocals as positive exponents. All right, in our next example, okay, we got a little more going on here. So let's simplify anything we can in numerators and denominators, and then we'll go between the numerator and denominator. So here, 2x to the negative second. Everything in the parentheses is to the negative second power. So this whole base and expression is going to move to the denominator. So let's start just by doing that. Okay? So we're going to have 2x to the positive second times negative 4 x squared y to the fourth z to the fourth. We can have everything inside those parentheses to the fourth power. And then the numerator, we're still going to have y to the fifth, z to the fourth. Okay, so now let's start to simplify. We can take what's in the parentheses here and square it. Okay, so let's do that next. So we can take this and we can make that y to the fifth, z to the fourth. So we haven't done anything there yet. Then we have 4x squared times negative 4x squared, y to the fourth, z to the fourth. Right? And now we can start to simplify here between the numerator and denominator. Okay, we have like bases, we can subtract exponents. So let's see what that will look like. So we're going to take y to the fifth over y to the fourth is going to be y to the first. We don't have to write a 1 as an exponent. Z to the 0. So z to the 0 is just 1, right? Those would just cancel out. We divide something by itself. You could write it as z to the 0, but in our final answer, we don't want to have something with a 0. We can just know it's times 1. And in the denominator, we have 4 times negative 4, which is negative 16, x to the fourth. And that would be our final answer. Typically, we might also write the negative in front of the whole fraction instead of in the denominator. Okay, so we have negative y over 16x to the fourth. And that would be our final answer. And it has only positive exponents, right? There's no negative exponents in any of our final answers here. So follow our properties of exponents, remembering what to do when there's products, when there's quotients, and now introducing instances where we're dealing with negative exponents, exponents that are 0, and how we can handle those situations as well.